On page 5 of the Chapter 2 activity, I have listed the weights of the apples, potatoes, and onions again. And I still have that data in my calculator. If I go to Stat Edit and I arrow back to the left, I can see that I've got my apples, potatoes, and onions over here, which is great. So what I'm interested now is getting the sample standard deviation and population standard deviation for both of these. So I don't want to do it by hand right now, so I'm going to exit out of this menu, which is my Stat Edit menu where I enter the data. So second quit, and then I go to Stat Calc, and I go to one variable stats. The list I'm interested in is second L1. And there is no associated frequency. Each of these is just entered once. So I clear that out, and then I go to calculate. And when I look at my results, I see that sigma is 5.4, and S, the sample standard deviation, is 5.7. I'm just keeping one decimal place on both of those. So that matches what we have over here. And then you can repeat that again for the potatoes and onions. So I'll just do this one more time. Second quit, Stat Calc, one variable stats, second L2, enter. Here are the things that I need. The sample standard deviation is 60.1. and the population standard deviation is 57.6. So wow, those are a lot higher. And the cool thing about this example is that I told you that this is a measure of the variation. And you can see that the potato weights vary a lot compared to the apple weights. And that's why we have a higher standard deviation for these. And then the onions are pretty similar to the potatoes. There's a lot of variation in weights. So 61.3 and 58.4 for the standard deviations. Yes, it makes sense that the onions had the highest standard deviation. That is a measure of the variability of the weights. So, okay, if you took Math 105, you may have learned to find the sample and population standard deviation of a set of data by hand. We're not going to do that. We'll just find these using the calculator. And if you did have a frequency list as well, then you could simply go to Stat Calc, one variable stats, and put your frequency list in another list and use it that way. But we didn't have that in this case. Okay, and then we need to talk about z-scores a little bit. The z-score is a measure of the weirdness of a data value. I just made that up. That it never says that anywhere, but I basically figured out that if you're above average, you're going to have a positive z-score. If you're below average, you're going to have a negative z-score. And if you are very average, you're going to be a z-score of 0. So maybe I didn't write this anywhere, but basically the z-scores go from -3, -2, -1. 0 means you're exactly average. And then 1, 2, 3. So 3 would be you're way above average. And then this -3 would be you are way below average. Now that might sound bad, but I guess if you had some things it might be cool to be below average, some things it might be cool to be above average, or maybe we want to just be average. I don't know. But anyway, here's the formula for the z-score. You take the data value, you subtract x bar, the mean. I'm going to erase what I wrote right here because it's kind of getting in the way of my formula. So here is the formula, data value minus the mean, and then divide by the sample standard deviation. So find the z-score of the 296 gram potato. I need to take 296 minus the mean potato weight, which was 154.1. And notice I'm doing that subtraction in parentheses so that when I divide that entire answer by 60.1. And I get 2.36. So this potato is way above average. It is 2.36 z-score. So it's more than 2 standard deviations above the mean. The 20-gram onion is super tiny. So to get its z-score, we take 20 minus the average onion weight, and then we divide by 61.3. So this one's well above average, negative 2.40, almost 2.5 standard deviations below the mean. And finally, the z-score of the 140-gram apple works out to 0.63, so that one's sort of average or maybe a little above average. And then here's sort of a tricky question. What is the weight of an onion if it had a z-score of negative 2? And I give you a little formula here to use. Use x equals x bar plus z times s. So here's my x bar plus, there's the z-score, times s was the sample standard deviation. So we multiply negative 2 times 61.3, and then we add 167.1, or you can do it in the order that I wrote the formula, plus negative 2 times 61.3. Okay, so that would be an onion that weighs 44.5 grams.